Hello everyone, welcome to our YouTube channel. Today we will discuss regarding aldehyde and ketones. They are categorized under carboxylic acid. Aldehyde and ketones undergoes nucleophilic addition reaction. So here we will discuss some important chemical reaction of aldehyde and ketones. First one is aldol condensation. Aldol condensation, remember one thing, that aldol condensation must require presence of this alpha hydrogen. Without alpha hydrogen presence, this reaction does not carry out. The starting material taken for aldol condensation is 2 molecules of acetaldehyde. See here, when we take 2 molecules of this acetaldehyde, they in presence of base that is OH, they form beta hydroxyaldehyde. It is also called as a aldol. See the reaction. This 2 molecule of, this is the structure of acetaldehyde, CH3 C double bonded OH, and this is second molecule. The second molecule, the CH3 is written as CH2H. When this reaction is carried out in presence of OH, this O and this H combines and form product. See in product, this CH3 as it is C, this bond breaks and this OH forms OH, and then this H and this CH2 combines, and here they form 3-hydroxybutanol. This is called as a aldol because it contains aldehyde and alcohol, same two different functional group in same product, that is ALD for aldehyde and OL for alcohol. Then same, when these two molecules of acetone, that is ketone, combine with each other in presence of barium hydroxide, that is BaOH by 2, they form 4-hydroxy 4-methyl 2-pentanone. Here this is the structure of acetone, CH3 C double bonded OCH3, and this is second molecule of acetone. In that, instead the CH3 is written as CH2H. Here same like that aldehyde, here also this O and this H combine and there is a formation of bond between that C and CH2. See the product CH3C single bonded OH, CH3 CH2 C double bonded O CH3. This is called as a ketone. The mechanism of this aldol condensation, this reaction is reversible and it involves the following step. First step is formation of enolate ion. What is, when the first molecule of acetaldehyde is reacted with base molecule, this OH is transferred, or this OH attracts proton from that CH3 and it forms water molecule, and there is a generation of enolate ion which is also called as a nucleophile. Okay, then in second step, this nucleophile is attack on another second molecule of acetaldehyde. See here, this is second molecule of acetaldehyde and this is our nucleophile. This nucleophile is attached to that acetaldehyde structure. See here, this carbonyl group shows resonance and forms negative ion, O negative, and this bond is break. Okay, then this CH2 is attached to that structure of acetaldehyde. Okay, and it forms CH3C single bonded O H, and then this break bond is useful to form bond between that CH and CH2, and then the second structure combines. See, in the third step, this negatively charged oxygen accept a proton from water to produce aldol. Okay, this carbonyl carbon shows negative charge, so obviously it undergoes self protonation, and here this self protonation adds hydrogen to its structure and it forms aldol, CH3CH OH, then CH2 C double bonded OH. This is aldol. Here the carboxylic group stands for ALD and OL stands for alcohol. It is called as a 3-hydroxybutanol. This is the mechanism of aldol condensation. Then our second reaction is cross-aldol condensation. This cross word indicates that there is a presence of two different aldehyde or two different ketone. When we take two different aldehyde like acetaldehyde and benzaldehyde in presence of base, they form third category of aldehyde, that is cinnamaldehyde. When we take benzaldehyde, this is the structure of C. The reaction benzaldehyde is reacted with acetaldehyde. Here the CH3 of acetaldehyde is written as CH2H. Then combine both the structure to form the third category of aldehyde. Then here this O and this H combine because of electronegativity, and here this C and CH2 form bond between them. Okay, this is the intermediate product formed in reaction. Here see the structure, benzene ring remains as it is. This C and O bond breaks and this O negative attracts H positive and forms OH, and here the bond between C and CH2 forms and the remaining structure as it is. This intermediate structure involves addition of proton. Addition of proton in and or heating. In presence of heat, this OH removed from this reaction. See here the structure. This is benzene ring C, H, this OH and this H is removed as water molecule, and there is a formation of double bond. This bond is shift between this C and CH2. Here C and CH forms double bond and remaining structure as it is, and there is a formation of cinnamaldehyde. Remember one thing, wherever there is a crossword, consider that we have to take two different aldehyde or two different ketone molecule. Okay, then next reaction is Cannizzaro reaction. In Cannizzaro reaction, there is no presence of alpha hydrogen. Okay, this is difference between Cannizzaro and aldol condensation. Aldol condensation contain or must require alpha hydrogen, but in Cannizzaro reaction they do not have alpha hydrogen atom. Okay, when the two molecules of aldehyde which do not contain alpha hydrogen are heated in presence of concentrated alkali like NaOH, they undergo self-oxidation and reduction. Here we called as redox reaction. They undergoes redox reaction. After reaction, the one molecule of aldehyde, that is one molecule of this formaldehyde, is reduced to alcohol, while the another molecule of this aldehyde oxidized to carboxylic acid salt, that is sodium formate. Consider the reaction that these are the two molecules of formaldehyde which lacks alpha hydrogen. In presence of base NaOH, here what happens? See, this NaOH is split as H positive plus ONa negative. Okay, then this H is attached to that carbon of first molecule of formaldehyde and it forms CH3. This or C bonded O, this carbonyl group shows resonance, and here this O gets negative and it attracts this H positive, and it forms, after attracting this H positive, it forms the first structure, that is CH3OH as a methanol. Okay, then the second remaining structure, that is this is remaining structure. Okay, then this structure, that is C double bonded OH, and it the remaining part of that is ONa, it is attached to that structure and it forms sodium formate. Okay, these are the two products formed in Cannizzaro reaction. Okay, when we take another example, that is when two molecules of benzaldehyde, that is reacted in presence of base, that is NaOH. Here this it takes hydrogen from this C takes hydrogen from NaOH, okay, and that is CH2, and this O, this C carbonyl group is breaks, and this O negative attracts the H positive of second molecule of benzaldehyde, okay. Then it forms benzyl alcohol, first molecule. Then see here, that is benzene ring C, it attracts the H from that NaOH, that is CH2, and this O attracts H positive and OH. So this is first structure, benzyl alcohol. See the remaining structure, benzene ring C double bonded O, and this is ONA. This ONA is attached to that one and forms sodium benzoate. Okay. See the reaction of Cannizzaro or mechanism. In mechanism there are two steps. First step is attack of this hydroxide ion on the carbonyl group or first molecule of formaldehyde. This nucleophile, that is OH, it is attack on the first molecule of formaldehyde and form a unstable carbocation structure. This C double bonded O group shows resonance. Here this bond breaks, O becomes negative, and this OH is attached to carbon. Okay, this intermediate or this carbocation involves hydride transfer. Here the second molecule of this formaldehyde reacted with that structure. Here the negative charge again or undergoes resonance and forms double bond. Here this H forms CH3, or this H and this C forms bond between them and forms CH3 and remaining structure as it is, or this bond shows resonance. Here this is the intermediate structure. See the structure HC, this bond transfer, that is C double bonded O, OH remain as it is. This H and this CH2 combine and form CH3, and this resonance shows negative charge, that is CO, O negative. Okay, this O negative pulls hydrogen from this hydroxyl group and forms CH3OH, that is alcohol, and this is, that is C double bonded OHO. This is hydronium salt and it attracts the Na, and here ONA is formed. Okay, the ketones does not give this type of reaction. Then our next reaction is cross-Cannizzaro reaction. As the name cross indicate that there is a presence of two different aldehyde. Ketones do not give Cannizzaro reaction, only aldehyde. So there is a presence of two different aldehyde. See the reaction. If one of the aldehyde is formaldehyde and one of the aldehyde is benzaldehyde, when these two different aldehyde combines in presence of base, that is NaOH, they forms one product as alcohol and second product as carboxylic acid, salt as sodium formate. Okay, all reaction is same, only there is a difference in cross Cannizzaro reaction is there is a presence of two different aldehyde. Okay, so first reaction or first benzaldehyde molecule gives benzyl alcohol and second formaldehyde molecule gives sodium formate. Next reaction is Perkin condensation reaction. In Perkin condensation, the reaction occurs between aromatic aldehyde. This aromatic should not contain alpha hydrogen, and aliphatic acid anhydride which contain alpha hydrogen. In presence of salt of acid anhydride, it gives alpha beta unsaturated aromatic acid. Okay, then see the reaction when this aromatic aldehyde, that is benzaldehyde, is reacted with acid anhydride in presence of acyl salt. Okay, that is CH3CONA. COONA. Under heating, it forms cinnamic acid and acetic acid. One thing should be noticeable that aldehyde is converting into carboxylic acid. under Perkin condensation reaction. When we discuss the mechanism, you should easily understand the reaction. Okay, see the mechanism in first step, that is dissociation of the salt. Okay, or which is catalyst, or which is shown on arrow, the dissociation of this group, that is acyl salt. Okay, CH3, it is dissociated into CH3C double bonded O negative plus Na positive. This CH3C double bonded O negative attack on acetic anhydride structure. See here, this CH3COO attack on acid anhydride and it abstract the hydrogen from that methyl group of acetic anhydride. Here this O negative abstract H positive and form CH3COOH. Okay, then remaining structure it forms as a radical CH2COO as it is. Okay, then this first structure is reacted, that is carbocation 1. Okay, this carbocation 1 is reacted with our benzaldehyde. Then there is a formation of this bond between that C and CH2. Because this carbonyl group shows resonance, here O forms negative charge and this bond is break and the bond between C and CH2 is formed. See the structure of second carbocation, C6H5, C single bonded O, O negative, then H positive, and remaining structure is attached to that carbocation. Okay, this is carbocation 2. Okay, this carbocation 2 contain negative oxygen. This negative oxygen due to electronegativity undergoes self protonation and it abstract proton, H positive ion. Okay, after abstracting proton it forms third carbocation structure, that is C6H5 C OH H CH2 C double bonded O CO CH3. Okay, then this CH2 is written as CH and H. Okay, this H and this OH is removed as a water from that reaction and forms fourth carbocation structure, that is C6H5C. As obviously this bond breaks here, so there is a formation of double bond between that C6H5CH double bonded CH, then other structure remain as it is. Okay, then it forms the fourth carbocation, that is called as cinnamaldehyde and acetic acid. Then our next reaction is benzoin condensation. When two molecules of benzaldehyde are reacted in presence of potassium cyanide as a catalyst, it forms benzoin. See the reaction, that is two molecules of benzaldehyde in presence of KCN as a catalyst, it forms or they are converted into benzoin. Here this KCN act as a driving force of this reaction. See the mechanism. The three steps involved in mechanism of benzoin condensation. First one is dissociation of cyanide ion. This cyanide ion is dissociated as K positive Cn negative. Second step is attack of this cyanide ion on first molecule of benzaldehyde. See here, this cyanide is attack on the benzaldehyde structure and forms the intermediate, that is benzene ring. This C double bonded O carbonyl group shows resonance and the bond between C and O is break and C and Cn bond is formed. Okay, this H is abstracted by that O negative due to electronegativity and it forms carbanion ion. Okay, benzene ring. In the third step, the resonance stabilize carbanion ion attack on the second molecule of benzaldehyde to form the oxide ion. See the structure, this is the carbanion ion and this is benzaldehyde molecule. Okay, there is a formation of bond between that C and that C group and overall structure combines to form oxide ion. Here This C carbonyl group shows resonance and there is a breaking of that bond. O carries negative charge, and here that this there is a formation of CC bond. See the structure: benzene ring COH CN C single bonded O H and a benzene ring. Okay, this is oxide ion. This oxide ion undergoes removal, or the cyanide group is removed from that oxide ion. Here see the structure: benzene ring C, this H is abstracted by that O, and here the O negative transfer, and there is a formation of double bond again. Benzene ring C double bonded O, and there is a removal of this cyanide group. Okay, and here the second structure C O H, and here H and benzene ring. There is a formation of that structure called as benzoin. Okay, if you understand the video, do like, subscribe and put your comments in comment section. Thank you.